Hello, today I'm going to talk to you about the evolution of the atom. The first scientist to come up with the model of an atom was Democritus in 400 BCE. Old Demo was in a very simple time, with no modern technology. As such, his model is also rather simple. He hypothesized that objects around him were simply made of very, very small pieces of whatever the object was, such as iron. He believed that iron was made of small pieces of iron, held together through hooks and loops. And clay was made of small pieces of clay, attached with balls and sockets, allowing it to be manipulated far more easily than iron. He also believed that cheese was made of small cheese and attached with more balls and sockets, obviously. He concluded that these very small things could not be cut any smaller. No one had any real breakthroughs after him for quite a while, until John Dalton came along in 1805 and was like, hey, I think this Demo guy was onto something. Started to do some research of his own. He says that atoms are the smallest pieces of an element, which sounds a lot like what the guy before him said, but I'm sure he wasn't stealing his ideas. Anyway, he also discovered that all atoms of the same element have the same fixed ratios within an object. Because, you can't make H2O with two O's. That just wouldn't be very tasty. He came up with his own drawing of what an atom might look like. A sphere. It's just a sphere. No creativity. His final claim to fame is his discovery that atoms can neither be created nor destroyed. Personally, I think John was a bit boring and uninspired. But thankfully we have J.J. Thompson, who in 1897 wanted to know a little bit more about these things. He saw that the atoms either had large negative charge or were thousands of times smaller than a hydrogen ion. He ran some complicated, wacky experiment that I can't seem to wrap my head around, but it looked like shooting an atom through a tube to see if it was charged. What he discovered was that the atoms had separate positive and negative charges within them, and so developed the plum pudding model to view an atom. Personally, I've never seen plum pudding, so I like to imagine it more as a chocolate chip cookie. This was a really big jump for the scientific community, sparking many discoveries and various new atom models in the early 20th century. Ernest Rutherford took what J.J. Thompson discovered and made a huge discovery with it in 1911 regarding the size of the nucleus of the atom. What he did was shoot alpha particles at a wall of gold foil, and it went something like this. Tink! One of the particles had bounced back, meaning the atom was mainly empty space with a small, dense nucleus, meaning his atom looked like this. Niels Bohr is the one who began to organize where the electrons might actually be on the atom. In 1913, he experimented by looking at the hydrogen emission spectrum. He saw that he couldn't see the full rainbow. He determined that the atom is only stable if electrons are in certain places around the atom, meaning his model resembled that of a solar system, and is known as the planetary model. This sparked a slew of a bunch of people in the 20th century throwing their models into the mix. I'd like to name a few of the notable scientists with an atom model. You've got this wacky group of fellows: Louis de Broglie, Erwin Schrödinger, Werner Heisenberg, and Paul Dirac. In the mid-1920s, these people did a whole lot of really complicated math to discover that electrons could act both as particles and waves, meaning their atom looked a little like this. James Chadwick made his model in 1932. Not a lot special about his model, but he had to throw it in there. And last but not least, Maria Meyer, who made her model in 1948 and just happens to be the only woman on this list. Thank you for listening, and goodbye.